Hi, I'm Hannah. I'm a tutor at Sky Academy. We're looking at the topic of algebra, specifically the subtopic non-linear relationships. So this is our third video in this topic, and we are looking at quadratic functions. So another name for a quadratic function is just a parabola. And a parabola is marked by the general equation of y equals ax squared plus bx plus c. And the simplest parabola would just be y equals x squared. Now, a distinguishing characteristic of a parabola is the x squared. So if you ever see x squared in a function, you can know that that is a parabola. In our previous videos, we looked at exponentials, and exponentials had the function y equals ax. So it also had a power in the function. However, if you have a look, the power for a parabola is the power of 2, and the power for exponentials is x. So x is the changing factor, and in an exponential, it's the power, and in a parabola, it's just the base. So that's the difference between the two. A to the power of x is exponentials, and x to the power of 2 is a parabola. So that's the difference between the two. It's just important to know that difference so you don't get confused. If a question says which of these functions is a parabola, you know that x to the power of 2 is a parabola. So with a parabola, as the one down the bottom, there's a few characteristics that are key and important to be aware of. So let's have a look at some of those. So here we will have the y-intercept. This is where it crosses the y-axis. We have x-intercepts. We don't always have x-intercepts, but we generally do have x-intercepts. And you can have two x-intercepts. So this is where it will cross the x-axis twice. We also have the turning points. So you can have a minimum turning point, or you can have a maximum turning point. So I'll just demonstrate quickly what a maximum turning point would look like, and I'll show you the difference between the two. So here, this one, that point there would be our max turning point. And so wherever the top of the parabola is, or the turning point, if it is above the rest of the function, it is the maximum turning point. And if it is below the rest of the function, it is the minimum turning point. So a maximum turning point is when x will be negative, and a minimum turning point will be where x is a positive. And because our parabolas are symmetrical on either side, they will have an axis of symmetry going down the middle, which will go to in line with either the minimum turning point or the maximum turning point, and that's the dotted line here. So let's have a look at a example of a parabola, and let's see if we can point out some of these features. But first, just quickly, here is a positive parabola where y equals x squared, and we have a minimum turning point here. And here is a negative parabola where y equals negative x squared, and we have a maximum turning point here. So here's our example. First thing we are going to do is substitute into the equation the values for x that they've given us, and we're going to find y. So I'll do an example where y equals x, we're going to do -4 squared. And if you put that into your calculator, you should get an answer of 16. Let's do the same for -3 squared. You'll get the answer of 9. And I'll just do one more quickly for -2 squared, and you'll get the answer of 4. And now I'm just going to go ahead and do the rest in of these x values. 0, 1, 4, 9, and 16. And as we know that a parabola is symmetrical, these values will create like a pattern, a symmetrical pattern. So if they do not create a pattern such as that, that might be an indication that you're doing it wrong. Now I'm going to draw up a number plane to graph this function. And if you have a look in our y, we have no negative values. So I don't need to use the bottom half of my number plane. I'm just going to use the top 2 quadrants. Like that. And I'm going to label that y and this x. And now I'm going to put on my scale. So on my x, I have to go to +4 and then -4. So I will just go across to 4, 1, 2, 3, and 4. And now I'll go across to -4, -1, -2, -3, and -4. And now I have to go up to 16. So I'm just going to go up by 2s. So we have 14, 12, 10, 8, 6, 4, and 2. 14, 12, 10, 8, 6, 4, and 2. Now I've got my scale. I'm going to put these points onto my number plane. So where x equals -4, y will equal 16. So about there. -3 on my x goes to 9. On my y, oops, that's not 9. This is 9 here. -2 goes to 4. -1 goes to 1. 0 goes to 0. And now we'll go up on this side, mirroring this quadrant. So 1 goes to 1. 2 goes to 4. 3 goes to 9. And 4 goes to 16. And now I'm just going to connect those dots. So it should make a symmetrical curve. And we have no x-intercepts except this point here. And we have no y-intercepts except that point there. So this is going to be also our axis of symmetry. And that point 0, 0 is also going to be our minimum turning point, because it is a positive x and a positive graph. So it's our minimum turning point. And that's how you graph a quadratic function.